Listen carefully, because everything you think you know about reality is about to fall apart. For most of your life, you've been taught a simple idea. Matter is one thing, energy is another, and the universe is built from solid, understandable blocks. That picture feels safe, logical, and complete. But it is not the full truth. It is only a simplified version your mind uses to survive without confronting something far deeper. Now imagine something almost insignificant. Half a gram of matter resting between your fingers, so small it feels meaningless, lighter than a few grains of rice. You would never suspect anything special about it. It looks harmless, silent, almost empty. Yet inside that tiny piece lies a reality that completely breaks your intuition. That fragment is not just matter as you imagine it. It is energy compressed into an incredibly dense structure, energy locked inside a microscopic prison. And if that prison were suddenly broken and all that stored energy released at once, the result would not be small or ordinary, it would be catastrophic. The energy released would be comparable to thousands of tons of conventional explosives, enough to erase an entire city in an instant. How can something so small contain that much power? The answer is not mystery or magic, it is physics. At the deepest level, mass and energy are not separate things. They are two expressions of the same underlying reality. Matter is simply energy in a condensed, tightly bound form. This single idea completely changes how the universe actually works. Look around you. The table, the ground, your own hand, everything appears solid and continuous, but that sense of solidity is misleading. If you could zoom in far enough, beyond what your eyes can perceive, you would discover that almost all of it is empty space. What we call solid matter is mostly vacuum. At the center of this emptiness lies the atom. And inside the atom, there is a tiny nucleus that holds almost all the mass. If an atom were the size of a football stadium, the nucleus would be no larger than a grain of sand sitting in the middle. Everything else is mostly empty space where electrons exist in constant motion. Inside that nucleus are protons and neutrons tightly packed together. Protons carry a positive charge, which means they should naturally repel each other with enormous force. According to ordinary physics, nothing should be able to hold them together. In fact, if only electrical forces existed, every nucleus in the universe would instantly explode apart. But nature has another force, far stronger and far stranger. It is called the strong nuclear force. This force acts like an invisible glue, binding protons and neutrons together. However, it only works at extremely short distances. It is powerful beyond imagination, but extremely limited in range. In small atoms, this balance works perfectly. The forces that push things apart and the forces that hold them together reach a stable equilibrium. But not all atoms are simple. Some are massive, unstable, and dangerously balanced. This is where uranium enters the story. A massive nucleus packed with 92 protons and 143 neutrons, all compressed into a tiny space. Inside it, an intense internal struggle is happening. Every proton is trying to push every other proton away, while the strong force is desperately holding everything together. But uranium is already at the edge of stability. It is not peaceful. It is tense, fragile, and constantly on the verge of breaking apart. And all it takes to disturb this balance is something surprisingly small, a single slow-moving neutron entering the nucleus. That tiny interaction is enough to begin a chain of events that changes matter itself into pure energy. And once that process starts, there is no way to stop what comes next. That single slow-moving neutron changes everything. At first, it seems almost meaningless, like a random particle drifting through space. But when it approaches a uranium nucleus, something critical happens. Instead of bouncing away or passing through, it is absorbed. The nucleus accepts it, and in that moment, everything becomes unstable. The uranium nucleus, already stretched to its limits, suddenly becomes uranium-236. This tiny change is enough to disturb a system that was barely holding together. Think of it like adding a single extra drop of water to an already overflowing glass. Nothing dramatic should happen at first glance, but the internal balance is already broken. Now the nucleus begins to vibrate violently. The forces inside it, which were already in a delicate tension, start to lose control. The protons at opposite ends of the nucleus are now too far apart for the strong nuclear force to hold them together effectively. Remember, this force only works over extremely short distances. It cannot stretch across the entire nucleus. At the same time, the electromagnetic force never weakens. Every proton is still repelling every other proton with full strength. And now, with the structure weakened, that repulsion starts to win. The nucleus begins to elongate, like a droplet of liquid being pulled in opposite directions. This is the breaking point. The structure becomes unstable, stretched thin in the center, until the binding force can no longer hold it together. At that exact moment, the nucleus splits into two smaller nuclei. This process is called nuclear fission. When the split happens, it is not gentle. The two fragments are violently repelled from each other by the same electrical force that was pushing them apart inside the nucleus. They shoot away at enormous speeds, carrying energy released from the destruction of the original atomic structure. At the same time, a few extra neutrons are released. These neutrons are extremely important because they carry the potential to continue the process. But initially, they move too fast. They are not immediately useful for causing further reactions. Here is the paradox. One breaking nucleus is not enough to create a massive explosion. On its own, it releases energy, yes, but it is tiny on a macroscopic scale. It is not enough to destroy anything meaningful in the real world. So the question becomes, how does this scale into something catastrophic? The answer lies in numbers. In just half a gram of uranium, there are trillions upon trillions of atoms. Each one is a potential source of energy. But they do not all react at once under normal conditions. Something is missing, something that allows the process to multiply instead of staying isolated. That missing element is control over the neutrons, because while fast neutrons usually escape without interacting, under the right conditions, they can be slowed down. And once slowed, they become capable of triggering more fission events. This is where the process stops being a single event and starts becoming a chain reaction. One nucleus splits, releases neutrons, and those neutrons go on to split more nuclei. What starts as a microscopic event begins to grow into something exponential. And once that exponential growth begins, the system is no longer a collection of isolated atoms. It becomes a self-sustaining cascade of destruction, building momentum with every generation. But to understand how that cascade becomes uncontrollable, we need to go one step deeper into how that chain actually multiplies. The chain reaction begins in the most unexpected way, not with force, but with density and probability. The neutrons released from the first fission are moving incredibly fast, almost like microscopic bullets fired in random directions. In normal conditions, most of them would simply escape without hitting anything meaningful. But when the material is sufficiently dense, something changes. These neutrons no longer have empty space to travel freely. Instead, they collide with nearby uranium nuclei. However, there is a catch. Speed matters. A neutron moving too fast will pass through or miss the nucleus without being absorbed. It is too energetic, too chaotic to be captured. For a chain reaction to sustain itself, those neutrons must slow down. When they lose speed, they become far more likely to be absorbed by another uranium nucleus. And once absorbed, they trigger the same instability process again, splitting another nucleus and releasing more energy and more neutrons. Now the system stops behaving like isolated atomic events. It becomes a multiplying sequence. One reaction becomes 2, 2 become 4, 4 become 8, then 16, 32, and so on. This is exponential growth, and it is the key to understanding how microscopic physics turns into macroscopic destruction. But this growth is not slow. It happens on timescales so small that they are almost impossible to imagine. In fractions of a second, trillions of atoms can undergo the same transformation, each one releasing energy not just as motion, but as intense heat and radiation. As this continues, the energy density inside the material rises dramatically. The fragments of split nuclei move violently, colliding with surrounding atoms and transferring their kinetic energy into heat. At the same time, high-energy radiation in the form of gamma rays spreads through the surrounding space, adding another layer of intense energy release. What was once a stable piece of metal becomes something entirely different. It is no longer a solid object in the everyday sense. It becomes a rapidly expanding region of extreme temperature and energy. Matter begins to lose its familiar structure. At such extreme conditions, electrons are stripped away and atoms are torn into a state of plasma. At this stage, classical intuition completely fails. There are no simple comparisons in everyday life that can capture what is happening. It is not fire in the usual sense. It is not chemical burning. It is a direct conversion of mass into energy through nuclear transformation. And yet, even this is only part of the story. Because the real shock is not just the energy release itself, but what that energy does to everything around it in the next instant. What happens next is where intuition completely collapses. The energy released from the chain reaction is not just heat in the normal sense. It is a violent mixture of kinetic energy, electromagnetic radiation, and subatomic debris, all released in an almost unimaginable concentration. At first, the fragments of split nuclei shoot outward at extreme speeds. These particles collide with surrounding atoms, transferring their energy in brutal, microscopic impacts. Each collision is like a tiny explosion on its own, multiplying the chaos inside the material. But this is only one part of the destruction. At the same time, a massive burst of high-energy radiation is released. This includes gamma rays and X-rays, forms of energy so intense that they can pass through matter and damage it at the atomic level. Unlike visible light or heat from fire, this radiation does not need air or fuel. It travels instantly and penetrates everything in its path. Inside the material, all of this energy gets trapped for a brief moment. There is no time for it to escape smoothly. Instead, it accumulates, causing the temperature to rise at a rate that defies everyday experience. In an incredibly short span of time, the region becomes hotter than the core of a star. At these temperatures, matter, as we know it, stops existing in its normal form. Solids, liquids, and gases all lose meaning. Atoms are torn apart completely. Electrons are stripped away, and what remains is a state of matter known as plasma, a chaotic soup of charged particles moving at extreme speeds. Now, this plasma does something even more dramatic. It begins to interact with the surrounding air. The intense radiation and heat ionize the atmosphere, stripping electrons from air molecules and turning the air itself into a conductive, glowing medium. The surrounding environment is no longer neutral, it becomes part of the reaction. This creates a rapidly expanding fireball, but calling it fire is misleading. It is not chemical combustion. It is a glowing sphere of superheated plasma expanding outward, consuming everything in its path. The expansion is so fast that it pushes air away with tremendous force, compressing it into a shock wave. And here is where the true mechanical destruction begins. The shock wave is not just wind. It is a wall of compressed air, moving faster than the speed of sound, capable of demolishing structures, flattening landscapes, and pulverizing anything that resists its passage. Meanwhile, the light from the explosion travels even faster. It reaches distant points first, delivering an intense flash of thermal radiation. This sudden burst of energy can ignite materials instantly, burn surfaces at long distances, and cause damage before any sound is even heard. In that moment, the event becomes something far beyond ordinary explosion physics. It is a complete transformation of matter into energy on a scale that overwhelms everything around it. But even this stage is not the final consequence, because after the light fades and the shockwave passes, something invisible remains, something far more persistent and dangerous than heat or pressure. And it continues to affect the environment long after the initial destruction has ended. That hidden aftermath is where the story becomes even more unsettling. After the initial blast, the environment appears to settle. The fireball fades, the shockwave moves on, and silence begins to return. But this calm is deceptive. What remains in the aftermath is not peace, but a lingering invisible danger that continues to reshape everything it touches. The split atoms created during the reaction are not stable. They are broken fragments of a once heavy nucleus, now left in an energetically unbalanced state. These fragments begin to decay over time, releasing radiation as they try to reach stability. This process is not explosive, but it is persistent, silent, and extremely harmful. These unstable elements release particles such as alpha and beta radiation, along with more gamma rays. Unlike the initial blast, this radiation does not create immediate visible destruction. Instead, it interacts with matter at a microscopic level, altering the structure of atoms and molecules it passes through. When this radiation enters living tissue, the consequences become biological. It does not burn or cut. It penetrates cells and damages their internal structures. Most critically, it attacks DNA, the fundamental code that controls how living organisms grow and repair themselves. Sometimes, the damage is minor, and the body attempts to repair it, but these repairs are not always perfect. Over time, small errors accumulate, potentially leading to mutations that can develop into serious diseases. In more intense exposure, the damage is too great for repair systems to handle, and cells begin to fail completely. This leads to a breakdown of essential biological systems. Tissues stop regenerating properly, the immune system weakens, and vital organs lose their ability to function. The danger is not immediate in the dramatic sense of an explosion, but it is slow, invisible, and deeply destructive. At the environmental level, these radioactive fragments do not disappear quickly. They mix with dust, soil, and water, entering ecosystems and spreading through natural cycles. Over time, they can remain active for years, decades, or even longer, continuing to emit radiation as they decay. What makes this even more significant is that the process is completely indifferent. It does not target life intentionally. It simply follows physical laws, releasing energy as it moves towards stability. But the result is a landscape altered at a fundamental level, where matter itself carries a hidden trace of the original reaction. And this brings us back to the deeper realization behind everything we have explored. What began as a simple idea about matter and energy has revealed a universe where nothing is truly solid, nothing is truly separate, and everything is governed by transformations at a scale far beyond human senses. The same physics that produces this destructive chain reaction is also the physics that powers the stars, including the sun that makes life on Earth possible. The universe does not distinguish between creation and destruction. It only follows energy, mass, and the rules that bind them together. And in that realization lies the final, unsettling truth about reality itself. Everything leads back to one unavoidable conclusion. The universe does not operate according to human intuition. What feels solid, stable, unpredictable is only a surface-level interpretation created by a brain that evolved to survive on Earth, not to understand the deepest structure of reality. When we look closely at matter, we do not find solid objects in the way we imagine them. We find mostly empty space, tiny dense nuclei, and invisible forces locked in constant tension. What appears to be stability is actually a carefully balanced struggle between opposing interactions, held together by rules that operate far beyond everyday experience. And when that balance is disturbed under specific conditions, the consequences are not gradual. They are immediate, exponential, and extreme. A single microscopic event can grow into a macroscopic transformation through a chain reaction, where each step feeds the next with increasing intensity. What begins at the atomic level can escalate into something that reshapes entire environments. But even this destructive potential is only one side of the story. The same principles that allow matter to release enormous energy are also responsible for the existence of stars. In the core of the sun, similar processes convert mass into energy, producing the light and heat that make life on Earth possible. Without these same physical laws, there would be no warmth, no chemistry, and no biological existence. This creates a deep paradox. The universe does not separate creation from destruction in the way human thinking does. It uses the same fundamental rules for both. The same equation that describes energy release in extreme reactions also explains the steady power that sustains entire solar systems. It is a single framework governing both life and catastrophe. From this perspective, matter is not truly solid, and energy is not something separate or secondary. They are two expressions of the same underlying reality, constantly shifting between states depending on conditions. What we perceive as physical objects are temporary configurations of energy, stabilized only for as long as the forces within them remain balanced. This understanding changes how we see everything around us. The ground beneath your feet, the air you breathe, even your own body are not fixed structures. They are dynamic systems, held together by delicate interactions at the smallest scales. And while they appear permanent, they are constantly involved in processes that could, under different conditions, behave in radically different ways. It also reveals something about our place in the universe. Human beings are not separate from these laws. We are built from them. Every atom in your body follows the same principles that govern stars, nuclear reactions, and cosmic evolution. The difference is not in the rules, but in the scale and stability of the systems involved. Yet despite this deep connection, our perception remains limited. We experience a simplified version of reality, one that filters out the extreme behaviors of matter and energy because they are not necessary for everyday survival. That is why the deeper structure of the universe often feels strange, counterintuitive, and even unsettling when revealed. In the end, what we call reality is not a fixed image, but a layered system of interpretations. Beneath the surface lies a world of constant transformation, where energy and matter continuously shift forms, bound by equations that do not care about human expectation. And once you truly understand that, even in the smallest way, it becomes impossible to look at the world the same again. Because everything solid becomes temporary, everything simple becomes complex, and everything familiar becomes a thin layer over something far more fundamental. The universe is not built for comfort or intuition. It is built for consistency in its own laws, no matter how strange the outcome appears from our limited point of view.